Warm welcome to everyone for the DC Machines and Transformers Laboratory. Through this short video lecture, I will give the introduction for the speed control on DC Shunt motor. Right? So, hope you have received this manual part, and out of this experiment, we are going to study the following method of speed control for the DC Shunt motor. One is field control method, another one is armature control method. And once you enter into the laboratory, this experiment will be carried out in the table number 18. You directly go to the table number 18 and get the nameplate detail for this particular machine, that is shunt machine, and you need to design the armature voltmeter, ammeter, and field ammeter. So fuses, everything you need to design, and this is what the circuit diagram you are going to do the connections. Right? Once the design part is over, you need to get the signature from the faculty to confirm that your design part was right. After that, you can give the indent slip to the technician. He will provide those meters and rheostats, everything. And rheostats also you need to design. So all these design things I was explained through the previous video classes, right? So you just refer that and design those components, and after received the components, you need to do the connections. For the connections, so you can take a wire from the positive terminal, and one wire can be connected to the armature rheostat fixed terminal. So this can be considered as fixed terminal. Another wire you need to connect to this field rheostat fixed terminals, right? So the variable end of the first rheostat should be connected to the very consecutive rheostat fixed terminals, and then the variable end of the second rheostat should be connected to the positive of the armature ammeter, and negative of the ammeter should be connected to the AA, and AA terminal should be connected to the ZZ, right? And the other side of the field coil, Z, should be connected to the negative of the ammeter, field ammeter, and positive of the field ammeter should be connected to the variable end of the rheostats, right? So now this connections was over, and remaining connections are across the AA. You need to connect the voltmeter positive. A positive should be connected to the A, and negative should be connected to the AA. And now this part is also over, and the remaining part is you need to take a wire from ZZ and you need to connect to the negative supply, right? So by the time this closed loop and this got closed loop and this also completed, so all the three loops or connections were completed. Now the procedure is just a minute. So the procedure is, first you can do the field control method. For the field control method, there is a table here, and so this is the field control method. Now for this field control method, you need to adjust the first armature rheostat so that the motor gets started, and fix some amount of voltage across the armature. Fix some amount of voltage across this armature V value, and that you can write it here, where VA1 has some value, maybe 100 or 200 or something, right? So you take 100 volts here. At this condition, you no need to do any modification here. You need to vary the field rheostat from minimum position to maximum position. So that time, for each condition, you can take the IF value, field current value, and corresponding IA value and corresponding speed via the tachometer. So tachometer, you can non-contact tachometer, you can focus towards the armature and you can measure the speed, right? And then after completing all this set of values, you bring back this field current to the earlier position, and you adjust the armature rheostat to some newer value of VA so that you will get some new value of VA2 here, and that should be recorded in this VA2. And after that, once again you need to adjust the field rheostats from minimum resistance to maximum resistance position, and for each and every case you need to take the IA, IF and speed, so and that can be plotted in the graphs. So this is with respect to the field control. For the armature control, the vice versa you need to do. So this is the table for armature control. So here adjust the armature rheostat so that the motor gets started, and then minimum amount you adjust, and then motor will be started, and then adjust the field rheostat to some fixed value, and that current will be considered as maybe 0.5 will be considered as the field current value here, and then you adjust the armature rheostat in a step-by-step manner. For each step, what is the armature current, what is the armature voltage you can measure, and the speed also you can measure, back EMF you can calculate, right? And this should be repeated for 4 or 5 times. So this you will get all these readings, and then once again adjust the field current to the newer set of value, and new IA should be IF should be recorded here, and once again you need to adjust the armature rheostat's value, and by adjusting the armature rheostat you can vary the VA, IA and speed. So all these things will be recorded, right? So now with this you can complete the speed control part. For the calculation you can go for the calculation you need an armature resistance value. So for that you need to connect this circuit diagram. So to connect the circuit diagram, once again in a similar manner, starts from the positive terminal and connect to the fixed end of the carbon rheostat, and variable end of the carbon rheostat should be connected to the ammeter positive. Ammeter negative should be connected to the armature terminal A, and armature AA terminal should be connected to the negative of the supply. And across the AAA A terminal you connect the positive of voltmeter, and negative of voltmeter should be connected across the AA. Now this connections were over. Now the procedure is you need to give the supply to the circuit diagram, close this DPST switch and adjust the carbon rheostat. Initially the resistance will be maximum, right? So when you adjust this adjustment, your carbon rheostat resistance gets reducing. For each value of R value you will get 1 ammeter reading and 1 voltmeter reading, and that should be recorded in the second table of speed measurement of armature resistance table, right? So for every corresponding V, what is the current, and so that you can calculate the RA, and this should be repeated for 4 or 5 times, and then the average will be considered as the average armature resistance, which will be utilized in the calculations of back EMF, right? So hope with this you can do this experiment easily. If you have any doubt you can ask in the class itself, right? So thank you for watching.